All right, ladies and gentlemen, welcome back. Today we're going to be talking about special right triangles. Now, special right triangles are really easy topic to think about. There are two of these right triangles. And the reason we call them special right triangles is simply that the ratios work out really nicely, but it goes a step further than that. It leads us into a discussion that'll take place over a couple of years. This is not something that is just a geometry topic, but it leads us into a discussion of something known as exact values. Now, real quick, just to highlight that, if I were to ask you what the cosine of 45 degrees was, every single one of you could pull up your calculator. Oh, let's make that smaller. Okay. And you'd make sure that your mode is in degree mode. And once you've checked that you're in degree mode, you would just plug in the cosine of 45. And you'd get this crazy decimal here. And that's great. But what if I told you that that answer was totally incorrect? By New York State standards, by general mathematics standards, you'd say, what? Right? So what happens here is it turns out that radical 2 divided by 2 is that same answer. And so what it turns out here is that the acceptable answer is actually radical 2 over 2. And they don't even accept 0.707167812 as an answer. So with special right triangles, we need to memorize two right triangles. Okay? And we would traditionally memorize these for the regions. Now, for those of you saying, well, there's no regions, so I'm not going to memorize them, don't go too fast. Algebra 2, need to know them. Pre-calc, need to know them. Pretty much any math class that you're going to take from here on out, you're going to want to know about these special right triangles. So, what makes these triangles special? Well, what makes these triangles special is the angles. So this is a 30, 60, obviously this is a 90, so that's a 30, 60, 90 right triangle. And this one here, obviously we have the 90-degree angle in the corner. This is going to be a 45, 45, 90 right triangle. And it turns out that the sides here are actually in a really nice ratio. So opposite the 1 is going to be, opposite the 30 is the 1. Opposite the 60 is a radical 3. And opposite the 90 is a 2. Now, there's a couple different ways to look at the right triangle here, but I'm going to look at it in the following way. I'm going to say that 1 is the hypotenuse, and we're going to say that radical 2 over 2 and radical 2 over 2 are the legs. Okay, so what does this mean exactly? What kind of questions can we see? Well, we're going to be asked about triangles that are similar to this. And if you remember anything about similar triangles, the sides are in proportion. Okay, so with similar triangles, the sides are in proportion. So what we're going to do here is we're going to look at this 60, 30, 90 right triangle. And so what we're going to do here is, let's see. Okay, so here's our Delta Math example, so you can complete the assignment. All right, bear with me while I jump back and forth. So we have a 2, 60, 30, and x. Okay, so what I always like to do, especially when we're starting out, is redraw the perfect right triangle, but draw it in such a way that it lines up. So what do I mean by that? Well, I'm going to put my 60 up here, my 30 here, my 90 is still there. Now, I'm making this the same. What do I mean by that? Well, the 1 is going to be here. So since the 1 is there, that means the radical 3 will be down here, and that means the 2 will be over there. And what I'm basically being asked here is for the ratio. I'm asked to solve for x, but I need to do that in a ratio sense. Now, the only way you're going to be able to create this ratio here, as you can see me doing, is if the triangles were drawn using the same orientation. If your 30 and 60-degree angles are backwards, not going to work. So what I'm doing here is I got to pick a top and I got to pick a bottom. So we'll go with the left to right. So 2 over x is equal to 1 over 2. Okay, cross multiply. So 2 times 2 is 4, 1 times x is x, 4 is equal to x. And it literally is that simple. Okay, now, they won't always be and they just had a different ratio there. That's no difference there at all. But they won't always be that simple, right? So sometimes there'll be a radical involved and things like that. Let's see if we can find one that might involve a radical. Yeah, let's look at this one here. Okay, so we got the x radical 6. Okay, so you'll remember that our traditional 45-45 triangle has sides 1, radical 2 over 2, and radical 2 over 2. So now that I've got them lined up, let's see what we can do here. So I'm going to create a ratio. I'm going to create a ratio. So x over radical 6 is equal to radical 2 over 2 over 1. Now, a couple of weird things here, but we can simplify. Whenever we divide by 1, we just get itself. So x over radical 6 is equal to radical 2 over 2. Now I'm going to cross multiply here. X times 2 is 2x. Radical 6 times radical 2 is radical 12. Okay, if you don't recall from Algebra 1, when we multiply radicals, we multiply the insides, we multiply the outsides. Now, radical 12 does simplify. Oh, let's go back. Radical 12 does simplify. So the largest perfect square to divide in is radical 4, and that leaves me with a radical 3. Now, radical 4 simplifies, so I get 2 radical 3. Okay, so now with my 2 radical 3, what can I do with that? Well, I can simply divide. What do I mean by divide? I can take 2x equals 2 radical 3, divide by 2, x equals radical 3. And that is my answer. And there I go. So I'm going to ask you to do a couple of those. Now, this topic might seem a little bit easy, but you got to remember that in reality, you would have had to memorize these two. You'd be doing it without basically being open notes. So a couple things there just to think about. All right, so again, special right triangles, really important topic because it does allow us to get answers without decimals, okay?